Hey guys, this is Miss Scott here. So today I'm going to work through a few problems with you on the Chapter 9 material that you'll find on the semester review. So let's start here with number 1. We have to simplify this rational expression or this fraction. So we're just really factoring everything that we can. So in the top, I noticed that 4r and 12 can have a 4 taken out, and then we'll be left with r minus 3. In the bottom, you should recognize that r squared minus 9 is a difference of squares, so we can factor that as r plus 3 times r minus 3. And now what we're doing is looking for any matches that we can cancel out. So you probably see that you have this r minus 3 in the top and this r minus 3 in the bottom that can cancel out. Then we just write our leftovers, so our answer would be 4 over r plus 3. Okay, now let's look at an example where we have to do some adding. And in number 2, the tough part here is that we don't have a common denominator. Well, we'll have to make one. The easiest way to do that is to just multiply each fraction by the other one's denominator. So I'm going to multiply this fraction by 2u, and I'm going to multiply the first fraction by 5. And then we'll just rewrite that. So in this first fraction, we end up with 15v over 10u, and the second fraction becomes 4u times 2u is 8u squared, and then 5 times 2u is 10u. And now notice that we do have a like denominator. So we can just add the numerators, which is 15v plus 8u squared, and that's just going to be over that common denominator of 10u. Now, you probably noticed this one, there's nothing that I can divide these coefficients by, but if it would be the case that 15, 8, and 10 would all be divisible by something, it's always a good idea to check that just to make sure that your answer really is in simplified form. But there's nothing that we can divide 15, 8, and 10 by, so this would be it. Okay, let's look at number 3. This one we're finding a quotient, or in other words, we're dividing two rational expressions, and we're going to have a lot to factor here. Before I even think about factoring though, I always like to just change a division problem into a multiplication problem. And remember, we can do that with keep, switch, and flip. So that means we keep the first fraction the same, we switch the division to multiplication, and then we flip that second fraction. Alright, so now let's go ahead and factor. In this first fraction, I can make a diamond, trying to find two numbers that multiply to negative 10 and add up to positive 3. So if we think about that, I think we're going to use positive 5 and negative 2. We'll do that. So let's rewrite that first fraction as x plus 5 times x minus 2. And we still have that x plus 3 in the bottom. Okay, over here in the second fraction, let's make a diamond using negative 15 and negative 2. So again, thinking of two numbers that multiply to give us negative 15 and add up to negative 2. And I think if we use negative 5 and positive 3, that will get us there. So this second numerator will factor into x minus 5 times x plus 3. And I don't think that I can do any diamonds with this 5x squared minus 25x, but I do notice that those both have a 5x. So we'll take 5x out, and that's going to leave us with x minus 5. So notice if we would distribute that 5x back in, we'd get back to 5x squared minus 25x. All right, now just like what we did in the first problem today, we're going to see if there's any matches that we can cancel out. So I think we've got this x plus 3 that we can get rid of. And we've also got these x minus 5s in the second fraction. And that looks like it. So let's rewrite our leftovers. In the top, we have x plus 5 times x minus 2. And in the bottom, we have 5x. And I don't see anything else that we can factor or anything else that we can cancel. So that would be our answer there. Okay. All right. Number 4 is actually maybe a little bit easier than number 3 because we just have a multiplication problem. So we can just do some factoring here. Kind of nice about this one, both these polynomials are the same, so we know that they're going to factor into the same thing. So we'll make a diamond with negative 16 and 6. So let's see, two numbers that multiply to negative 16 and add up to positive 6. I think we'll use positive 8 and negative 2 to do that. So let's just rewrite that in factored form. That would be r plus 8 times r minus 3. And then we actually have the same fraction, or the same numerator over here. So we have, again, r plus 8 times r minus 3. And that's over 7r squared. And you probably would have guessed that these would cancel because they are the same. So we're just left with r plus 3 in the top and 7r squared in the bottom. Okay. All right, now number 5 is a tough one. This is what we call a complex fraction because it's fractions within fractions. So the first thing that we should do here is get this denominator here into a single fraction, because then what we can use is keep, switch, flip. All right, so let's find a common denominator here. I'm going to multiply the top and bottom of the first fraction by u, and the top and the bottom of this second fraction by 4. So you can probably notice when we do that, we'll have a common denominator of 4u. All right, here we're going to have to distribute the u, so we get u squared minus 1u. And in the bottom, u times 4 is just 4u. And then in this other fraction, we'll distribute the 4, giving us 4u minus 4. And the bottom again is u times 4, which is 4u. So now that we have a common denominator, we can add these fractions. And I'm looking for any like terms in the top. So I have u squared, and then notice I have negative 1u plus 4u. So that's going to give me a positive 3u, and I have the minus 4. And that will all be over 4u. All right, so what we've done is we've turned that denominator into a single fraction. So we are going to, in our second step, make this a division problem. So we've got u squared over 4, and we're going to divide that by this fraction here. So instead of writing out the division, I'm just going to do keep, switch to times, and then let's right away flip that fraction on the bottom. So we put the 4u in the top, and the u squared plus 3u minus 4. That goes in the bottom. And I don't see a whole lot that's going to cancel here. It looks like the only thing that cancels out in this problem would be these 4s. So let's just multiply our leftovers straight across. In the top, u squared times u is u cubed. And in the bottom, I have u squared plus 3u minus 4. Okay. And I don't think there's anything else we can do with this, so that would be our answer here. All right. Okay, one more problem here. We have to solve this equation here. So in this case, we have to figure out our least common denominator and multiply all of the tops by that denominator. And in most cases, the least common denominator is your biggest denominator. So that's what we're going to multiply all of the numerators by. So we'll multiply this 1 by n plus 2, we'll multiply this 3 by n plus 2, and we'll multiply this 2n minus 2 by n plus 2. And you might notice that quite a few of these are going to cancel. This n plus 2 in the bottom will cancel with this n plus 2 here. This n plus 2 in the last fraction will cancel with the n plus 2 here. So if we rewrite what's left over, we have in the first fraction 1 times n, which is 1n, and 1 times 2 will give us plus 2, equals, in the next piece we are just left with 3 because everything else canceled, and that last fraction we're left with plus 2n minus 2. Alright, so now that we've gotten rid of all of the denominators, we can just solve this like we normally would. So first thing I'm going to do is combine these like terms on the left. I can combine this 3 and negative 2. So I end up with 1 plus 2n on the right hand side. And I'm going to subtract this 1n from both sides, which is going to give us 2 equals 1 plus 1n. And lastly, I can subtract 1 from both sides, so these ones here will cancel. 2 minus 1 gives me 1 equals 1n, or just equals n. So my answer for this equation would be 1. And remember, it is always a good idea just to double check that this answer doesn't make any of these denominators equal 0. Well, if you plug in 1, you'll get 1 plus 2, which is 3, so you can have a denominator of 3. That's okay. Alright, so what I would like you guys to do is on the semester review packet, go ahead and give the chapter 9 section a try.